Okay, we're on the last chapter of Unit 1 in your physics book, Conservation of Momentum. So let's get going here. We'll start by drawing our template for your Cornell notes. And we'll take that question, how are kinetic energy and momentum got a little messy there. Momentum similar to and different from one another. Okay, so you've heard us and you've been in other science classes. You have a general understanding of kinetic energy versus potential energy. And you also have a general idea of momentum. We talk about momentum in everyday life, right? So, how are they similar? How are they alike, right? And how are they different? Tell me what you know or what you think. Okay. Hit pause and answer that. Okay, good. Hopefully you had a chance to write down a few bullet points or a sentence. So let's jump right into this. Momentum. If I think about a ping pong ball rolling or I think of a bowling ball rolling, I would say that the bowling ball has more momentum, right? And the first thing that should come immediately to mind is that the bowling ball has a lot more mass. And maybe mass is something that's related to momentum. Um, here's the fundamental, here is another fundamental physical quantity. I'm looking at sentence number 2. Okay, momentum. There's other fundamental quantities. There's things like mass, position, velocity, acceleration, force, energy. You've been learning these things. You've been writing out definitions. So, what is momentum? If I take a look down here, scroll down a little bit, I can see there's this definition. Momentum is equal to the mass of an object, just like we said, times velocity. All right. Well, let's go ahead and start with that, okay? Momentum is equal to mass times velocity. Okay. And if we come back over here and click on the vocabulary, make sure we don't miss anything here. And you can watch these animations and these videos, but I'm going to click on details. A quantity of how much inertia a dynamic object has. Okay, so that's nicely articulated. Let's go ahead and write that down. It's a quantity of how much inertia a dynamic object has. A dynamic, and a moving object, a dynamic object has. Okay, so we have a written out definition and we have a mathematical definition of that as well. Okay. And we're going to go ahead and just downsize our definitions here. And let's continue to move through our page here. Similar to energy, momentum can be transferred between objects. You know that if you are on the playground, basketball court, soccer field, and somebody runs into you, you're going to be knocked off of your feet, right? Because there is a transfer of energy that is happening there. Similar to a car accident, the energy from the car that hits you is going to be transferred into your car. Maybe it's going to bend up your fender. Maybe it's going to do more damage than that, right? Okay, let's read the second paragraph here. It says, similar to energy, I'm reading right in here. Momentum can be transferred between objects. Okay, we said that. This helps describe the motion of objects or systems, especially with collisions. And my pen stopped working, so I'm just going to use my finger here. So this helps with collision ideas. And the momentum, notice the symbol here, P with a vector arrow over it, of a mass, M, traveling at velocity, V, is a vector quantity defined as P equals M over V. Okay, that's maybe something new for us. So letter B here. We can go ahead and say that P is equal to the mass of the object times the velocity of the object, okay? This is very similar to the definition up above, right? I'm going to go ahead and just, here's our mass, right? There's our mass, and here's our velocity, right? We're just using this symbol right here for momentum, okay? This symbol here is going to be representing momentum, okay? And what else do we want to say? The momentum, P of a mass traveling at velocity. Okay, yeah. Okay, it looks pretty good. The momentum of an object is the same as the direction of an object's velocity. Well, that makes sense. Okay. What can we say then here? Letter C. Momentum helps describe the motion of objects, especially collisions. Okay, that might be the best way to say that. We also could say that momentum is in the same direction as an object's velocity. Okay. Mass is given in kilograms. Velocity is given in units of meters per second. This means that momentum has units. So let's go and write this down as well. The units for momentum. Since we say that momentum if P equals mv and mass is in kilograms, right? And velocity is in meters per second, then m times v is going to therefore your units are going to be kilograms times meter over second. Okay, that's going to be your units when we're talking about momentum. Okay. Right there. Okay. Okay. Watch this video here and talk about momentum. And as we move down, our notes are going to now compare momentum to this idea of kinetic energy. All right, I'm going to make this Roman numeral 2. I'm going to drag my line down just a little bit, Roman numeral 2. And this will be kinetic energy. Okay, remember we talked about kinetic energy as being the energy of motion or the energy of movement. And if you recall, energy is the ability to do work, right? Recall that kinetic energy is energy associated with the motion of an object. I'm reading sentence 1, and we have a formula here. Ke is equal to 1/2 times the mass of an object times the velocity of an object squared. Hopefully you see that there's some similarities. The mass times the velocity is similar to the mass times the velocity in momentum. Should make sense. Kinetic energy has to do with movement, and momentum has to do with movement. So both of them are going to have mass and velocity as part of their formulas, right? Okay. As in your text here, they talk about similarities, but they, just like we talked about, the mass and velocity are something that's similar. One difference that's worth noting is that kinetic energy is a scalar quantity while momentum is a vector. Okay, so maybe we can make that distinction. Kinetic energy is a kinetic energy, Ke, is a scalar quantity, whereas momentum versus momentum, which is a vector quantity. Okay. Okay. One additional, I'm looking at the yellow down here. I'm here. One additional distinction is that the units for the quantities are different. Kinetic energy has units of joules, which are the equivalent to Newton meters or kilogram meters squared per second squared. Note that the units of momentum are simply kilogram meters per second. Okay, so what they've done there is they've given you some equivalent units there. Joules is what we often refer to when we talk about kinetic energy, but you can see what the equivalents are there, or this as well. Okay, all right, these are equivalent measures there. Okay, kinetic energy. Let's just put this down. Measure in joules. Okay, which is capital J. All right. And look at that. That's it. That wasn't too bad, was it? All right. So it looks like in review here, we talked about kinetic energy. We talked a little bit about the similarities to momentum and some of the differences. And we especially were examining momentum. Okay. So your job now is to watch some of these videos, just kind of start to cement these ideas into your brain. Click on the vocabulary words because they have animations and they have videos as well to assist you. Okay. What I'd like you to do now is just go ahead and knock out your summary paragraph. Okay. And that's it. We'll talk to you later. Bye bye.